Welcome back. In the previous lecture, we started with hypothesis testing, and we said that statistical inference has two legs. We have estimation, and then we also have hypothesis testing. So for hypothesis testing, we start out by making a claim, and then we collect evidence, and we have to decide whether we stick to that claim or whether we reject the claim. So we have two hypotheses, the null hypothesis and then the alternative hypothesis. We start out by assuming that the null hypothesis is true, and then we collect evidence, and based on that evidence we have to make one of two decisions: to either reject the null hypothesis in favor of the alternative or not to reject the null hypothesis. Now, of course, we also have the possibility to make the wrong decision. If we wrongly reject the null hypothesis, so if we reject the null hypothesis when in fact it is true, but we do not know that, then we make a type 1 error. And the probability of making a type 1 error is called, or we indicate that usually with alpha, and we call that the level of significance. And then we also have a type 2 error, and the type 2 error is if the alternative hypothesis is true, but we do not reject the null hypothesis, then we make a type 2 error. Okay, in this lecture, I am going to work through the whole process of testing a hypothesis, just to give you an intuitive feeling of how hypothesis testing works. And then in the lectures to come, we will refine this process. A car manufacturer claims that the average fuel consumption in liters per kilometer of a specific model car is less than 5.8 liters per kilometer. The manufacturer takes a random sample of 20 cars of this model and subject them to a road test of 500 kilometers. The sample mean fuel consumption is X bar 5.7 liters per kilometer. Now, from previous experience, we can assume that the population standard deviation of fuel consumption is equal to 0.22 liters per kilometer. So when we have something like this, the first thing would be to specify our hypotheses. So if you read here, in the example, that the car manufacturer claims that the average fuel consumption is less than 5.8 liters per kilometer. So our alternative hypothesis would then be that the mean is less than 5.8. And you will remember from the previous lecture that our null hypothesis will be the hypothesis where we have the equal to sign. So our claim, or the manufacturer's claim, is reflected in our alternative hypothesis that the population mean fuel consumption is less than 5.8, and then our null hypothesis is that it is 5.8, actually implied 5.8 and more. Okay, so that's the first step, to set up our hypotheses. Now the second step is to collect evidence, and then based on this evidence we have to decide whether we reject the null hypothesis or not. So if you read through our example again, what is the evidence that we have? We took a sample of 20 cars. The sample mean fuel consumption was 5.7, and we also know that the standard deviation is 0.22. So that is the evidence we have. So on this slide, I have copied down the evidence and also our null and our alternative hypothesis. And now, based on our evidence, we must decide whether we reject the null hypothesis or not. Now, the first thing that you will ask is this 5.7, the sample mean, is that far enough to the left of the 5.8, which is stated under the null hypothesis? Is it far enough from the 5.8 to reject the null hypothesis in favor of the alternative? Now, I think some of you might say that 5.7 is close enough to 5.8. We do not have to reject the null hypothesis. And there might be people that say that 5.7 is far enough to the left of 5.8. We can reject the null hypothesis in favor of the alternative. Suppose I had a sample mean that was 4.9. I think that would be easy to say if the sample mean was 4.9, we can reject the null hypothesis in favor of the alternative. Or suppose that the sample mean was 6.5. Now that 6.5 is far to the right of 5.8, and we will not reject the null hypothesis in favor of the alternative. But now we have the situation where the sample mean is 5.7. What do we do? Do we reject the null hypothesis or not? So if we have our null hypothesis, which is 5.8, for this situation here, where the sample mean is 4.9, we say it's far enough from 5.8, we can reject the null hypothesis in favor of the alternative. Or if we had the sample mean, this one here, of 6.5, we can say it's far to the right of 5.8, we cannot reject the null in favor of the alternative. But now the situation is that we have a sample mean of 5.7. Some might go with the null hypothesis, some might go with the alternative. So what we actually need here is to find an objective cutoff value. And so that we all agree that if my sample mean lies to the left of that cutoff value, we will reject the null hypothesis. And if it lies to the right of that cutoff value, we will not reject the null hypothesis. So now the question is, do we put the cutoff value, we will call that cutoff value C, do we put it there, or do we put it there, or do we put it there? We don't know where we will place that cutoff value. So on the next slide, we are going to develop a method to find this cutoff value. Okay, and we have to go back to sampling distributions that we have covered in previous lectures. Now remember we said that if my population, my random variable x, follows a normal distribution with a mean mu and a variance sigma squared, then the sample mean for a sample from that population has the same population mean mu and a variance of sigma squared over n, where n is my sample size. So if the fuel consumption x follows a normal distribution, then the mean fuel consumption for a sample from this population will also follow a normal distribution. So we will use this information, and we will also set our probability of a type 1 error. We will set that equal to alpha. And we use this to develop a cutoff value. So we say that alpha, which is the probability of a type 1 error, that is to reject the null hypothesis when the null hypothesis is true. So we can rewrite it as the probability that the sample mean lies to the left of the cutoff value. So that is to reject the null hypothesis if it lies to the left of our cutoff value, given that the null hypothesis is true. Now the null hypothesis, remember, is stated that the population mean is equal to 5.8. So I have rewritten the first step here. I have rewritten it here. And now in the third step, we will standardize. Remember, if you think back on the lectures on the normal distribution, how do we standardize? We subtract the mean and we divide by the standard deviation. Okay, so if I do it on the left for the x bar, I must also do it for the c. So I take my c, I subtract the mean, and the mean is now given as 5.8. So I subtract the mean and I divide it by the standard deviation. Now the standard deviation is sigma over square root n. It was given to us that the population standard deviation is 0.22 and divided by the square root of the sample size, and we are working here with a sample of size 20. So I divide by this factor 0.22 over the square root of 20. And then in the last step, we know that if we standardize a normal distributed variable, then we can indicate the standard normal variable with z. So the probability now that z is less than this is equal to alpha. I have copied down here again the commonly used confidence levels that we worked with in the lectures for the normal distribution, and also we use this quite a lot when we have set up confidence intervals. Okay, so for example, if my alpha is 0.05, so if my level of significance or the probability for a type 1 error is 0.05, then we know that the probability that z is less than or equal to z, or rather minus z 0.05, that probability is 0.05. If I make my normal distribution graph here, the probability that it is less than minus 0.05, that area or that probability is 0.05. And z 0.05 is 1.645, and therefore minus z 0.05 will just be minus 1.645. So we can now set this value here, we can set that equal to minus 1.645. And from this, we will solve for C, our cutoff value. Now to solve for C, we will just multiply this minus 1.645. So we will take the minus 1.645 and we will multiply it with the standard deviation, which is 0.22 over the square root of 20. And then we will add the 5.8. Okay, and if we do that, we solve for C equal to 5.72. And now we have an objective cutoff value. So it's quite a process to get to this objective cutoff value. In the lectures to follow, you will see that we can streamline this quite a bit, but this is the theory behind the whole cutoff value. So if we go back to this slide, we have now found an objective cutoff value, which is 5.72. And if my sample mean lies to the left of that, I reject the null hypothesis. If it lies to the right of the cutoff value, I do not reject the null hypothesis. Now my sample mean, or for this example, the sample mean was 5.7. It is less than the cutoff value, 5.72. So we can say there's sufficient evidence to reject the null hypothesis in favor of the alternative at the 5% level of significance. And we can now make our final conclusion. We say there's enough evidence from the data to accept that the manufacturer's claim that the average fuel consumption of this specific model car is less than 5.8 liters per kilometers. Okay, just to summarize what we've done here, we started out by making a certain claim. So we have stated our hypotheses. Then we have collected sample data or evidence. Then we have calculated a cutoff value, and based on this cutoff value and the sample information, we have made a final, or we have come to a final decision and conclusion.